Ladies and gentlemen, distinguished guests, and fellow enthusiasts of technology, welcome to an exhilarating journey into the realm of basic instruction execution cycle. My name is Dhruv Sharma, and on behalf of E8 Group of First Year Vishwakarma Institute of Technology, I am delighted to stand before you today to embark on this captivating adventure. Today, we'll dive deep into the inner workings of computers, unraveling the magic that brings instruction into life. Together, we'll discover the intricacies of how Computer Central Processing Unit executes instruction, transforming line codes into the tangible actions. So, fasten your seatbelts and get ready for an unforgettable exploration of basic instruction execution cycle. Before we begin our expedition, let's take a moment to outline the exciting itinerary that awaits us. In the next few minutes, we'll journey through the various stages of basic instruction execution cycle, unraveling the secrets of how computer processes instructions. Here's a sneak peek of our agenda. First, we'll dive into the significance of basic instruction execution cycle. Next, we'll uncover the three core steps of the cycle: memory access, execute, and write back. These steps form the backbone of instruction execution, and we'll explore them in detail, understanding their roles and importance. Once we have a solid foundation, we'll dive deeper into each step. We'll start with fetch, the stage where CPU retrieves the next instruction from the memory. Then we'll move to decode, where the CPU deciphers the instruction's opcode, understanding its purpose and required operation. From there we'll explore the execute command, where the CPU performs the necessary calculations and manipulations to execute the instruction. Finally, we'll touch upon the write back, the stage where CPU updates the results and prepares for the next instruction. As we progress, we'll discuss optimizations and enhancements found in the modern CPUs, allowing for faster and more efficient instruction execution. We'll also explore real-life applications and examples, showcasing how the basic instruction execution cycle is so vital in powering various technologies we encounter daily.
Hello, my name is Dhriti Nair, roll number 43 from Division E. Instruction is a command which is given by the user to a computer. Execution is the process by which a computer performs instruction. Now, instruction execution means a program to be executed by a processor that consists of a set of instructions that are already stored in a memory. Now, the basic instruction cycle is a fundamental concept in computer architecture and refers to the sequence of steps that a processor goes through to execute an instruction. This process involves fetching an instruction from the memory, decoding it to determine what operation needs to be performed, executing the operation, and storing the result back in the memory. To know more about the instruction execution cycle, there are certain important terms needed to be remembered, such as program counter, memory address register, instruction register, memory buffer register, control unit, arithmetic logic unit, accumulator, etc. Cycle consists of 4 steps: fetch, decode, reading access from the memory, and lastly executing the instruction. This would be further explained in detail by my fellow groupmates.
Hello all, this is Vinit. Now let's focus on the final step of the basic execution cycle, executing the instruction. This is where the magic happens. Once the instruction has been fetched and decoded, the CPU moves forward to perform the required operations. During the execution phase, the CPU carries out the necessary calculations, logical operations, or data manipulations as dictated by the decoded instruction. It accesses data from registers or memory, performs mathematical calculations, and executes logical operations such as comparisons or conditional branching. This step is crucial as it brings the instruction to life, transforming abstract code into meaningful actions. It is the heart of the execution cycle, where the power of the CPU is harnessed to to execute tasks with incredible speed and precision. Now, let's take a closer look at the relationship between an instruction and its execution. An instruction is composed of an opcode which specifies the operation to be performed and operands, which are the data on which the operation is applied. Once the instruction is decoded, the CPU fetches the required data from registers or memory. It then performs the operation specified by the opcode on the operands, producing the desired result. This could involve arithmetic operations like addition or multiplication, logical operations like AND or even more complex operations specific to the instruction set architecture of the CPU. The execution of an instruction can involve accessing data from multiple sources, performing calculations, and storing the result in registers or memory for future use. It is through this process that the CPU executes instructions following the precise steps defined by the basic execution cycle. Moving forward, to provide a visual representation of the instruction execution cycle, let's explore a flowchart that illustrates the steps we have discussed so far. The flowchart demonstrates the sequence of the basic execution cycle. It starts with the fetch step, where the CPU retrieves the next instruction from memory. The instruction is then decoded in the decode step, determining the operation and operands. Once decoded, the CPU proceeds to the execute step, where the necessary operations are performed. Finally, the write-back step updates the results, completing the execution of the instruction. This cyclical process continues with the CPU moving on to fetch the next instruction and repeating the steps for seamless instruction execution. Thank you.
Hello everyone, this is Dhruv Chaudhari from Division E, Group 8. So, the first step in basic execution cycle is fetch. During the crucial stage, the CPU ventures into the vast expanse of memory to retrieve the next instruction that awaits its turn to be executed. To achieve this, the CPU relies on dedicated components known as program counters. The program counter keeps track of memory address where the upcoming instructions reside. With the program counter in hand, the CPU sets off its quest to fetch the instruction. It traverses the intricate web of memory, seeking out the precise location indicated by the program counter. Once it arrives at the designated memory address, it eagerly snatches the instructions and brings it back to its domain within the CPU. Now, securely tucked away within the CPU's internal registers, the instruction stands ready for the subsequent steps of the execution cycle. The fetch stage sets the foundation for the CPU to comprehend and unleash the power encapsulating within the instruction. Moving on to our next step, which is decode. As the CPU acquires the instructions, it ventures into the second step of the basic execution cycle, decode. In this stage, the CPU unearths the mysteries concealed within the fetched instruction, deciphering its purpose and unlocking its hidden potential. To unravel the instruction secrets, the CPU focuses on the opcode, the operation code embedded within the instructions itself. By meticulously analyzing the opcode, the CPU gains insights into specific tasks that the instructions command.
Hello everyone, my name is Dhruv Mulay and I am from E Division. My roll number is 46. So now we will look into step 3 of the basic instruction execution cycle. Step 3 of the basic instruction execution cycle is memory access. During this phase, the central processing unit fetches the instruction from the memory that needs to be executed. The program counter points to the memory address of the next instruction. The CPU retrieves the instruction from that address and brings it into its internal registers for further processing. The step 4 is execution. With the instructions now securely in the CPU, we move on to the execution phase. The CPU decodes the instruction, determining its operation and operands. It understands what task needs to be performed based on the opcode, the operation code embedded within the instruction. Once decoded, the CPU carries out the necessary calculations, logical operations, or data manipulations. It might fetch data from registers or access data stored in memory to complete the desired operation. The last step of the memory basic instruction execution cycle is called write back. As we reach the final phase of the execution cycle, we encounter write back. In this step, the CPU updates the result of the executed instruction. If the instruction involved a calculation or manipulation of data, the CPU writes the computed result back to the appropriate destination. This could be register or a memory location, ensuring that the outcome of the executed instruction is preserved for further use. By performing this write back, the CPU finalizes the instruction execution and prepares itself for the next instruction in the execution cycle.